If you or a loved one is living with cancer, you probably have two focal points: how to rid yourself of it and how to prevent it from coming back. You'll get some terrific information today on Cancer Concepts and Complements with Dr. James Belanger. We'll explore natural medicines which may enhance conventional therapies, share cutting-edge research, and offer insight on how diet and natural medicines can play an important role in treating and preventing cancer. The information presented herein is in no way intended as a substitute for medical counseling. Now, here is Dr. James Belanger.
Hello, welcome to Cancer Concepts and Complements. I'm your host, Dr. James Belanger from the Lexington Natural Health Center. Today we're going to talk about melanoma, mostly metastatic melanoma, but everything I'm going to say today will also apply if you have been diagnosed or a family member has been diagnosed with melanoma and you want to keep it from coming back. Unfortunately, it has a high rate of spreading. It tends to be a very aggressive type of cancer that can metastasize early, and that's the thing that I want to talk about today, and helping the immune system see melanoma cells that might not have been removed surgically to help the immune system eliminate it. There's a lot of research being done on immune therapies for melanoma, and it can respond well to immune therapies, but there's a lot of issues with the immune system, a lot of abnormalities that develop in the immune system in people with melanoma, and that's how it tends to come back and avoid the system and spread places. And the current therapies are a lot better than they used to be, but still there's a lot of research that needs to be done, and more research really should be dedicated to some natural medicines that address things that the current drugs are not addressing. But melanoma is the fifth most common type of cancer in men right now in the United States, and the seventh most common cancer in women in the U.S. It affects white people more than African Americans, 30 times more common in white people. But there has been some really big breakthroughs in melanoma just within the last 10 years or so. Before, it definitely had worse prognosis for people, but they've developed some immune therapies which have been really helpful. But I'm going to talk about all these different ways that the cancer can get around these current immune therapies, and I see a place for natural medicine in conjunction with these current immune therapies to address all the ways that the cancer gets around the current therapies. But the first immune therapy that was approved, well, should I say a newer immune therapy approved called ipilimumab or Yervoy. Before it was using interferon and interleukin-2, and those didn't help that much. But Yervoy has been shown to be more helpful. Yervoy is a drug that basically blocks something called CTLA-4. Basically, when our immune system is activated, there's different cells activated, but there's a cell called the T cell, and the T cell can bind to a cancer cell and like poke holes in it, perforate it, destroy it that way. But there's a check and balance system, so our immune system has ability to shut itself off so things don't go haywire and our immune system attack our own body. So there's this regulating protein on the surface of T cells called CTLA-4, and when that gets expressed, the T cell is calmed down so it doesn't lead to overwhelming tissue damage in our body. Well, they have developed this antibody, which is ipilimumab, to this CTLA-4, and so it prevents our T cell there from being calmed down, and it can continue to attack the cancer. The only trouble is, of course, like I said, the CTLA-4 is there for a reason to prevent our immune system from attacking our own body. So this Yervoy can cause a hepatitis where the immune system attacks the liver. It can cause a colitis where the immune system attacks the colon. It attacks the thyroiditis, things like that. So people can get pretty sick from it, end up in the ICU unit with some of these other things, have to be treated with steroids to calm down the immune system, but then it can respond to the cancer at the same time. So there's a lot of natural things I'm going to talk about that don't have that effect. I wish they would do more research on that, because ipilimumab, it does help about 10 to 35% of the people, 10 to 35% depending on the study. And most of the time, it just keeps the disease stable. It doesn't shrink it that much. Stable disease for over 24 weeks. So that's a good amount compared to what they were before. And then people start to progress after that. A medium survival, Tends to be 10 to 13 months, they say. But the other trouble with, besides all those side effects that I mentioned, it's $30,000 every 3 weeks. $30,000, and you're supposed to have 4 treatments of this. So there's all kinds of immune therapies I'm going to talk about today, natural medicines that are looking promising in animal models. That's the trouble. They're only studied in animals, maybe a few small human studies that are like, $20 a bottle for a month's supply versus this $30,000 every 3 weeks. Some of these newer drugs are getting more and more expensive. They're really exciting. They're targeting certain things on the cancer, but very, very expensive when there could be something natural out there that's a fraction, a minuscule amount of the price, and still be just as effective, but they need to dedicate more research to it. Well, so this ipilimumab is one drug, and then there's a new drug that just got approved, pembrolizumab, or Keytruda, which also affects another negative regulator. So again, we have these things on our T cells, these proteins that calm them down, keeping them from leading to too much tissue damage and cell death. So there's this PD-1 compound that is present on a T cell that when it's expressed, it shuts down the T cell so it doesn't lead to too much attack. Well, the cancer cells can express this protein. They call it a PD ligand that will bind to this PD-1 receptor and kind of shut off the T cells so the T cell won't attack it. So they have this antibody, pembrolizumab, that will bind to that particular thing, preventing the cancer from shutting off the T cell, and it continues to attack. And it does tend to have a lot less side effects than ipilimumab. Again, it doesn't work for everybody. Response rate is roughly 25% of the people. It's been fairly newly approved. The studies I've read says that it works for about at least 7 months before things start progressing, but not 100% response, 26% response. But again, this thing is very expensive, $150,000 a year for this treatment. But it doesn't cause the side effects as much as Yervoy or ipilimumab does: fatigue, itching, rash. But I'm going to talk about some other natural medicines that, again, fraction of the cost, that can help our T cells and our killer cells continue to attack cancer cells that they should do some more research on. Then there's another group of drugs that are also brand new on the market for melanoma, that they don't affect the immune system. They affect a growth factor pathway called they're BRAF and MEK inhibitors, they're called. When a cancer cells have these docking sites, should we say, receptors for growth factors on their surface. And when something binds to these receptors, it stimulates growth and proliferation, replication of the DNA of the melanoma cells, and blood vessel growth as well. And so they have developed drugs that affect these pathways. So when a growth factor binds to the melanoma, these signaling systems won't take place as much. But the trouble with these is you have to have a particular mutation to qualify for these drugs. So you have to have a BRAF mutation. It's a mutation in one of the genes that codes for a protein that leads to growth. And if you don't have this particular mutation, then this one drug, Zelboraf, won't be indicated for you. And about 50% of patients with melanoma do have this mutation. So there's a good group of people that have it. But even when they do have it, only 52% will have a response to this drug, and it lasts about 6 months on average. The reason why these drugs don't work forever is because there's many growth factor pathways, should we say, that are upregulated. I'll give you an analogy. Think of this Zelboraf drug is creating a roadblock in the road, and that's your favorite way to go to work. And so you can't go that way, and after a while you learn a different route and go around it. So cancer cells will upregulate other pathways to get around it, and that's why this doesn't work that long, and it doesn't work in everybody that has the mutation. There are natural things that can affect other growth factor pathways that I'll touch on today as well. Again, this drug is pretty expensive, $9,400 a month for this particular drug. And it just affects one particular pathway, and it can cause rashes and joint pains and fatigue, and has some side effects a lot of the natural things I'm going to talk about, very few side effects, if anything. And what's important too about this Zelboraf is it can cause another type of skin cancer called the squamous cell cancer in 23% of people. So it helps one cancer of the skin and maybe cause another one. Then there's another two drugs that are given together, Menkinist and Talfinlar. I don't know who names these drugs, but that's what they're called. And they're both attack this BRAF and then this other mutation called this MEK gene. And there's a response as well to that, about 10 months for people that happen to have those mutations. It doesn't cause the skin cancer as much as the Zelboraf does. Only 7% develop that skin rash. But it's 7,600 for the Talfinlar and 8,700 for Menkiniст. And 5% of patients develop renal failure from it. So interesting stuff, putting a lot of money into these drugs. I'm reading natural medicine studies showing that there's natural medicines that can affect this BRAF and MEK that don't cause these kinds of side effects. For example, green tea. We'll get into that. All right, so let's talk about a normal immune response to cancer. This is the normal immune response. I always tell people to think of an analogy as somebody coming to your house and inspecting your house and saying, hey, you got a problem with your roof. And then you get on the phone after meeting with the inspector and you call somebody to come by and fix the roof. Then those people come by and they fix the roof and it all takes place and everything's good. So we have these cells that I call inspector cells, but they are called dendritic cells. And we also have a couple other inspectors in our body. One's called the M1 macrophage and then the B cells. But the dendritic cells are the best inspectors because they have long arms like an octopus. And so they can take samples, many samples of healthy cells, cancer cells, basically proteins that are, should we say, falling off of cells that end up in the vicinity of the dendritic cell. They take them and they migrate to a nearby lymph node. And when they get to a nearby lymph node, they present these proteins that they found on their arms to these T cells, what's called a T helper cell. And the T helper cell has the ability to recognize, are these normal proteins from normal healthy cells? Are these proteins from a cancerous cell? And if it's something that needs to be addressed, the T cell and the dendritic cell come together and there's these compounds that are made. One's called TNF and the other is called IL-12. It basically just gets the T cell, the T helper cell that is charged up. It's just like you meeting with the inspector and they say, you got a big hole here in your roof. And you're like, whoa. And then you get on the phone right away and you do something about it. You don't ignore it. The T helper cell, when it comes into contact with the dendritic cell or these M1 macrophages and the B cells, the inspectors, these compounds are produced or should be produced, IL-12 and TNF alpha. And then what happens is the T helper cell then starts to expand, clone itself, replicate. The more messengers on the job, the better. It's like if you cloned yourself, you could call a lot of people. I mean, you might not want to do that for your roof, but if you're trying to raise money or something, you clone yourself and there's a lot of people involved and you get the message across faster. So that's what our body does. We'll clone this one T helper cell that is specific for that particular protein that inspector found. And then so it then will migrate into the area where the cancer is and release compounds that activate killer cells. Natural killer cells and killer T cells. And these compounds are released. One's called IL-2 and one is called interferon gamma. And then the killer cells will respond and destroy these cancer cells. So it's very similar. Again, you call somebody and they show up at your house and they fix your roof. But there can be problems that occur along the way. Like I mentioned, maybe the inspector doesn't see the issue to notify you. Maybe you don't, the phone line is cut, should we say? Or maybe the killer cells never make it to the cancer, or like the people never make it to your house because of some roadblocks. Or maybe if they do show up, they don't do a very good job at fixing the roof. So there's all these issues that happen in the immune system. And the ipilimumab drug and the PD-1 inhibitor that I just mentioned only affect part of the immune system. They don't affect this whole cascade of reactions that take place. And that's why they don't work in 100% of people, and they don't last forever as well. And things can change. Cancer can do things to get around the immune system. So I'm going to expand those things. So, yeah, sometimes what happens is the cancer overexpresses something called TGF. TGF is a way to keep the inspectors out of the area so they don't inspect. The inspectors don't show up at your house, they can't find the problem with your roof. Cancer cells can overexpress this thing called TGF, transforming growth factor beta, melanoma cells that is, and then the dendritic cells will not be on the job, or the M1 macrophages to even recognize them in the first place. Or the cancer may surround itself with a set of guards, I call it, or they also call it suppressor cells, that prevent the T cell from being activated by the dendritic cell. So there's all these different cells that surround the cancer. One's called the myeloid derived suppressor cell, which I'm going to talk about, and the regulatory T cell. These are cells that are from our own body that normally we don't have that many circulating in our blood. But the cancer cells can release compounds called chemokines, which cause the bone marrow to produce an excess amount of these suppressor cells. And then these suppressor cells start to accumulate around the cancer, and they can release that TGF, that thing that I just mentioned, to keep the dendritic cells from seeing the cancer in the first place. They also inhibit the production of that TNF and that IL-12, those things that are needed to activate the T cell. So this is like, cutting the phone line. They message is never sent, then the killer cells don't arrive, because the whole proliferation signaling that needs to take place is being squashed by these suppressor cells that are forming in the area. We have suppressor cells like these for a reason. If we didn't, our body would develop autoimmune diseases. Our immune system could have started attacking itself. So we have these regulatory T cells, for example, and a little bit of these myeloid-derived suppressor cells to keep our immune system from over-attacking. When they start to accumulate, then they keep the immune system attacking the cancer. So it just uses some natural cells that we have in our body and uses it to its advantage. So there's natural things I'm going to talk about that can help reduce these cells. And this is going to be important, too, if you're on ipilimumab or this new PD-1 inhibitor, as a way to help them continue to work, because they have found that these cells are the things that stop some of those immune therapies from working, because they accumulate around the cancer. Other issues can be that you just don't have a big army. Sometimes radiation's involved, like if a tumor is starting to hurt or something, they might radiate it. Radiation often knocks down the lymphocyte counts. Lymphocytes are the types of cells that fight the cancer, like the killer cells, the T cells. Sometimes if a patient doesn't have too many lymphocytes present, then they can't fight the cancer in the first place. It's like not too many people show up your house to fix the house. It's not going to get fixed. Yeah, so there could be lower numbers of killer cells. Or lastly, the killer cells might not be functioning properly. When they do happen to get there, they don't kill the melanoma cells very well. The melanoma cells can make things that, should we say, weaken the killer cells, keeping them from releasing the compounds they need to destroy them. And there's some natural compounds, certain mushrooms, that are very useful for that. Okay, so I'm going to take a break, and now we're going to get into specific natural things that help each part of the immune system that can help it make it work better against melanoma. This is Cancer Concepts and Compliments.
This is Cancer Concepts and Compliments with Dr. James Belanger. The information presented herein is in no way intended as a substitute for medical counseling. If you would like to find out more about the Lexington Natural Health Center, please visit lexingtonnaturalhealth.com. That's lexingtonnaturalhealth.com. Now, back to this week's program.
Hello, everyone. Welcome back to Cancer Concepts and Compliments. I'm your host, Dr. James Belanger. Okay, before the break, I was talking about various abnormalities in the immune system that can develop in people with melanoma. Now, I'm going to take each part of those apart and talk about natural things that can help each part of the immune system. So the first thing I mentioned is we have these inspector cells called the dendritic cells and other inspectors like M1 macrophages and B cells that if you don't have enough of them, well, then the inspection won't take place, and the melanoma won't be detected in the first place. Well, it's a common thing that there might not be enough of these inspectors on the job in the vicinity where the melanoma is, because the melanoma can produce this thing I mentioned, TGF beta, transforming growth factor beta. Well, there is a study done, and this is an interesting study, measuring coenzyme Q10, which is a compound we make in our liver. It does get depleted when you're on statin drugs, like, Lipitor and stuff, but we do make it in our body as long as we're not taking statin drugs, and it's made in the same pathway as cholesterol in our liver. Well, they did a study done in the Journal of American Academy of Dermatology in 2006 in Italy, where they measured the coenzyme Q10 in patients with melanoma and 125 volunteer controls, and patients that had melanoma had lower levels of coenzyme Q10, and those that developed metastasis had even lower levels. They looked at survival rates in those that had coenzyme Q10 levels over 0.6 milligrams per liter. 80% of them were still alive at 80 months, whereas 0% were alive at 80 months if they had lower levels than 0.6. And the mechanism of how coenzyme Q10 might work, there's many mechanisms, but one of the things is it does help increase the numbers of inspectors on the job, like those macrophages, the dendritic cells, and even the T cells. So very interesting study, very simple thing that can be done, measuring coenzyme Q10. Various labs like LabCorp measure that, and making sure that you are above that 0.6 milligram per liter unit. And they have, coenzyme Q10 supplements that can be taken. It is made in our body. It's found small amounts in food, but it does get depleted with statin drugs. So that's concern that might affect the coenzyme Q10 levels. So TGF is something that can be measured to also see if you have a high level of this TGF. Well, that can lead to low levels of dendritic cells in the areas where there is cancer. They have found that there's a study done in Germany in the British Journal of Cancer in 1998 showing that patients with metastatic melanoma had higher levels of this TGF beta in their blood compared to those that it hadn't spread and compared to controls. So the higher that TGF goes up, the more likely there won't be enough inspectors on the job. And you also learn that TGF inhibits killer cells and T cell activity, like killer T cell activity. So it's something that can be measured. It's measured at a lab called Cambridge Biomedical in Massachusetts here. And it's an easy, simple test to check. And you want to see that be in a normal range. Well, if it is high, one of the natural compounds that I'll prescribe is neem. Neem is a leaf that's from a tree that grows in India. It's the neem leaf, not the neem oil. The neem leaf has been studied for helping to lower TGF beta in animals given melanoma. It's a study done in Immunotherapy Journal 2011 where they measured TGF beta and it was reduced with neem, and that led to a reduction in the melanoma and a decreased spread of it too. That was really important. Melanoma does tend to spread to places like the lung and the liver and the brain, and it reduces the migration, the spread, because it helps, when a melanoma cell has to spread somewhere, it's traveling through the lymphatic system, travels through the blood system, and what's in the blood and the lymphatic system are these immune cells, like these dendritic cells, these killer cells. And if those are functioning properly, melanoma cell on its own out there swimming around should be detected and destroyed. But if the immune system is not functioning well, then the melanoma can easily travel without being detected and end up in the lung, the brain, the liver, and start to grow. And TGF is something that if it's high, because it's being secreted by the melanoma cells or other cells that surround the melanoma, then it will have a force field around it, protected. You lower that TGF beta, and then that will stop that from happening. What's nice, too, about this neem leaf compound is that it also increases the interleukin 12, the IL-12, and gamma interferon. IL-12, if you recall, is a necessary substance needed to activate T helper 1 cells, and IFN gamma is necessary to activate killer cells. So it helps increase the activation of the immune system and decreasing one of the suppressive factors. Another thing that has been studied for lowering TGF, if some people that TGF is very high and neem leaf is not enough to lower it, then there are proteolytic enzymes that can be helpful. So there are enzymes naturally present in foods like pineapple stems called bromelain. It's in the stem of pineapple they find called bromelain. And papain, which is in green papaya, has been studied. A study was done in the Czech Republic in Life Science Journal 1998, where they gave animals these two enzymes rectally. They used a compound, a mixture called Wobi mucose of papain, and it has some other enzymes as well in there. And then they inoculated the mice with melanoma cells, and some of the animals were cured. 30% were cured from this. They never developed any signs of melanoma, even though we injected a bunch of cells into them. The other group that was not cured, there was a prolonged survival by 58% compared to the control group. And they didn't carry out the study very long, about 38 days, but usually when they inject all these melanoma cells in these animals, they start to metastasize very rapidly and grow, and the animal dies pretty quickly. So when they added this enzyme, it helped stop some of that, and the mechanism has been studied for this is maybe to lower TGF, so it helps to increase the number of inspectors on the job and the immune system's activation. It's also bromelain itself and papain have been studied individually as well, so they know that each one of those enzymes seems to have activity. So that has been studied. Another thing has been studied is shiitake mushroom. Well, actually, should I say not the mushroom, but what's called the mycelia, the root system of shiitake, the part that grows under the ground. But I'm going to get into that later when I talk about another cell. Okay, so that's TGF. So TGF is lowered, and that's great. But we also want to see a lot of what's called IL-12 and Tnf Alpha being produced. I mentioned that when the inspector comes in contact with the T helper cell, what should happen is this IL-12, interleukin 12, they call it, should be produced in a good amount, and TNF alpha should be produced in a good amount. Then the T cell, the T helper 1 cell, will start to proliferate and expand, clone itself, so that more messages will be sent that there's cancer somewhere in the body. Well, that's a common thing that interleukin 12 or TNF alpha may not be produced very well because the melanoma is releasing, for example, TGF and other things that keeping it from producing that. But there are natural things that have been studied to actually improve the production of IL-12 and TNF alpha from the dendritic cell and T cell. And one of them is called xanthan gum. Xanthan gum, if you do any gluten-free cooking, they use that as a thickening agent. It adds some structure to the baked good, but it's gluten-free. But it's this compound. It's called a polysaccharide. It's like a carbohydrate molecule produced by a bacterium that grows on plants called Xanthomonas campestris. Well, but they use it as a thickening agent in the food industry. But it does composed of these polysaccharides. They call them beta-glucans, which you probably heard of. Beta-glucans are found naturally in yeast, mushrooms, and oats, for example. But it's found in xanthan gum. Well, this particular study in the International Immunopharmacology in 2009 gave mice about 1 milligram of xanthan gum, which is not that much. It's like a teaspoon or so in a person. And they gave them once every 5 days after doing inoculating these mice with melanoma. And then after 40 days, they looked at the size of the cancer in the control group versus the xanthan gum group. And the control group, the tumors were 7 times bigger. And the mice, should I say, that had the xanthan gum, 40% of them survived beyond 100 days, where all the control mice died after 46 days. So xanthan gum is really cheap stuff. And if they did a human study and they got a similar effects on that, that would be really, really good, because compared to those drugs that I just mentioned earlier, how expensive they are. And how does this thing work? It helps our dendritic cells and our macrophages, those inspector cells, produce more TNF alpha, more IL-12, and it enhances even the killer cells, the killer T cells and natural killer cells. And you can't take a ton of this stuff. It's a fiber, and so if you don't drink a lot of water, maybe it can cause some issues with your gut. But a teaspoon is all they ended up giving these animals, and that's very well tolerated. And xanthan gum can lower cholesterol as well in people, and help make you feel more full and stuff if you have some obesity issues. So it's a well tolerated product in small amounts, and interesting studies done in animals here. Well, that's not the only beta-glucan containing compound that seems to help the immune system fight melanoma. There's some in mushroom, the maitake mushroom. They call it the MD fraction, that has been shown as well to help prevent melanoma from spreading places by activating the TNF alpha and interleukin 12 pathway. So I check those things. You can check those with a blood test. And, these cells, these macrophages or monocytes, they're called. These are the cells that they're in our blood, and they give rise to dendritic cells and macrophages, and you can measure B cells and stuff. They're in the blood, and you can take them out of the blood and provoke them, should we say, using compounds. One's called PHA and one's called LPS, but they're compounds that will stimulate these cells in the blood and see what they will produce. If they start to produce a lot of interleukin 12 and TNF alpha, well, then we know that the immune system can produce a lot of those things, and it's a good thing. They call that a production assay, interleukin 12 production assay, TNF alpha production assay. If you see, the cells, the white cells aren't producing a lot of these compounds, well, then when they arrive at the site where the melanoma is, if they arrive at all, they're not going to produce a lot of those things to help activate the whole immune system. So you can measure that. There's a lab called Pharmacin Labs in Wisconsin that does these production assays. And it's very common with melanoma or all kinds of cancers for interleukin 12 not to be elevated, and sometimes TNF alpha. And if they aren't, then the xanthan gum, the maitake, these are some other things that can be used to help their immune system start to produce more of this interleukin 12. And that's a crucial step in the immune response. It's not the only step, but it's one step that needs to be corrected. So now these dendritic cells are able to activate these T helper 1 cells with the help of IL-12 and TNF alpha. But what happens if you don't have enough T cells on the job? Doesn't matter if they become activated. There's not going to be a lot of messages sent, and a lot of killer cells aren't going to arrive if you don't have enough on the job. So there's a simple test. It's called a lymphocyte count. Most people have this done, but I don't find doctors really pay much attention to it. But the lymphocyte count, if you don't have enough lymphocytes in the blood, lymphocytes include the T cells, the B cells, and the natural killer cells. And many of these lymphocytes help fight the cancer. Not all of them, but many of them. And so there's a study done at the Memorial Sloan Kettering in New York, published in Cancer 2010 journal, where all they did was assess the lymphocyte counts in patients with metastatic melanoma after 2 doses of that ipilimumab drug. So they gave 2 doses, they measured the lymphocyte count, and if the lymphocyte count was less than 1,000, none of the patients had any clinical benefit from ipilimumab. If it was over 1,000, 51% had some kind of clinical benefit. Either the disease was stable or reduced. And then even more importantly, that it correlated with survival. After 2 doses, if the lymphocyte count was over 1,000, the 6-month survival was 75%, the 12-month survival was 47%. If they had a lymphocyte count less than 1,000, 0% 6-month survival, 0%. Why? Well, because ipilimumab helps, those T cells, become activated so that they will, or preventing from being turned off so they'll attack. But if you don't have a lot of T cells in the first place, then there's nothing to turn on, nothing to attack. So it's very important to have plenty of lymphocytes. Ipilimumab will not increase lymphocyte counts. There is actually no drug out there that's approved that will increase the number of lymphocytes. And I mentioned anybody who's had radiation, that will even lower them even more. And, radiation may be useful for pain relief and stuff, but it should be a last resort because it can really paralyze these lymphocytes, reducing them. Well, there are several compounds that have been studied to improve the lymphocyte count in animals with melanoma, and one of them is the Neem Leaf, like same thing I mentioned earlier for TGF. Well, neem leaf, the leaf extract, when it's extracted in water, there's compounds in there called isoprenoids and polysaccharides. It's studied in the International Journal of Immunopharmacology in 2004, showing that basically the animals, their survival was much more improved. 70% of the mice were alive at 100 days after neem leaf versus 0% were alive 90 days after neem leaf. And how did it work? It increased the numbers of lymphocytes, besides its effects on lowering TGF. So it activated the lymphocytes, and at the same time, it increases the numbers, which ipilimumab doesn't do, or the PD-1 inhibitors. And this stuff is very cheap. Really wish they would do more research. Very encouraging stuff. A whole bunch of stuff. Animal studies on neem leaf. Now, this is the leaf. I have not found any toxicity from it. You'll read about toxicity with the oil, the seed oil, but not the leaf extract. Another thing that I will use, so I'll measure lymphocyte counts. I always want them to be over 1,000. If neem leaf isn't doing it, then I use thymus. Thymus is actually my first go-to, but there is less research on thymus in melanoma. But thymus is a gland that we have in our chest, and it does become less active as we get older and older. Well, but it's active in kids, and it's active in calves. So some researchers have decided, let's give people with cancer thymus extracts from a calf and see if it helps the immune system. And there's a study done in an International Journal of Immunopharmacology in 1983 where they took patients that were healthy, and then they took patients with cancer, and they were just cancer in general, not melanoma, so their immune system was somewhat deficient. And they took their white cells out, and they incubated them with melanoma cells outside of the body. And then they saw, do these people's white cells respond to these melanoma cells outside of the body? And they found that the white cells, from the cancer patients, did not respond well to the melanoma. But the healthy people, it did respond well, and the white cells proliferated and expanded themselves. Well, if the people were treated with thymus extracts and then their white cells were mixed with the melanoma, then they were able to respond to it. So I always use thymus extracts, especially in patients with less than 1,000 counts, as it might help increase their numbers and help the lymphocytes expand and react to these melanoma cells. Okay, I got to take another break. When I get back, I'm going to talk about other mushrooms, like something called AHCC. This is Cancer Concepts and Complements.
This is Cancer Concepts and Complements with Dr. James Belanger. The information presented herein is in no way intended as a substitute for medical counseling. If you would like to find out more about the Lexington Natural Health Center, please visit lexingtonnaturalhealth.com. That's lexingtonnaturalhealth.com. Now, back to this week's program.
Hi, everyone. Welcome back to Cancer Concepts and Complements. I'm your host, Dr. James Belanger. Okay, let's continue our discussion about the immune system and melanoma. So I was talking about interleukin 12 and Tnf alpha, how it's important for those to be produced and to have a lot of lymphocytes. Those are many of the cancer-fighting cells. But you don't want just any old lymphocyte. There are types of lymphocytes that actually suppress killer cells, and one of them is called the regulatory T cell. And if you expand that one, well, then that might shut off the immune system's ability to attack the cancer. So, but neem has been shown to actually increase the killer cells and the ones that attack the cancer. So it doesn't just increase any lymphocyte. Another one that has been studied to increase the numbers of tumor-destroying T cells and killer cells is AHCC. AHCC is a mixture of polysaccharides like carbohydrate molecules, amino acids, fats, minerals, all these things from the cultured broth of the shiitake mushroom or the shiitake mycelia, the root system. So there's these compounds that come out in this broth that contain some compound called AHCC, which is called active hexose correlated compound. It's similar to what I mentioned in Xanthan Gum, but it's called an alpha glucan instead of a beta glucan. Well, anyhow, they gave mice this AHCC for 7 days, and then they gave melanoma. They actually did it beforehand, and then it significantly delays the tumor development. They still develop the tumors because It doesn't help every part of the immune system, coupled together with other things that might help, but entirely. But the tumors were a third of the size after day 20. But what was really important at this one is it increased the activation and the proliferation of what's called interferon gamma producing CD8 T cells. These are killer T cells. They're a type of lymphocyte that kill cancer cells, and this nearly doubled the amount of those present in the tumor of these animals. And it nearly doubled what's called the natural killer cells, too, so it increased the army. But I have not found it raises interleukin 12 or TNF alpha. It doesn't lower TGF. So that's why this particular study by itself did not find it to be that effective. And tumors were 1/3 of the size, but they did give it for beforehand, too. You combine that with something that lowers TGF, like Neem or proteolytic enzymes, bromelain, something that increases the production of IL-12, this and that, and now you have more cells on the job. So combinations of natural medicines might work better, but I have not seen studies where they're using them all together. That's what I do in the clinic, and I do the labs to make sure that these things are improving and the whole immune system is working together. Okay, now, once the T cell is activated by these the dendritic cells and these inspectors, and IL-12 is produced and TNF alpha, then we have what's called IL-2 should be produced. IL-2 is something released by the T helper 1 cell, and it stimulates the activity of killer cells, natural killer and killer T cells. You don't produce enough IL-2, you're not going to respond very well to the cancer. There's research, Journal of Biology Response Modifiers, 1986, finding that patients with melanoma have significantly decreased amounts of IL-2 produced by their white blood cells, and especially those with metastatic disease. And this is something that can be simply measured. That same lab I mentioned, Pharmacin Labs, that does IL-12, not to confuse it with IL-2. The IL-12 production, they do that. They also do interleukin 2. So they take a blood sample and they stimulate the cells and see, are they producing a lot of IL-2? If they're not producing a lot of IL-2, well, then that's a problem. Then the T cells are not going to be able to activate, the T helper 1 cells, activate the killer cells. So if that comes back low, one of the common things that I will put patients on is the herb astragalus. Astragalus is a root used in Chinese medicine and Chinese cuisine. And there's a study done in the Asian Pacific Journal of Cancer Prevention 2014 where they gave mice melanoma, and then 24 hours later they gave them astragalus, or they also combined the astragalus with something found in blueberries called pterostilbene with a P-T-E-R-O, pterostilbene. And the group that got the combination of the astragalus with the pterostilbene had the best reduction in the cancer and the less metastasis. But the cancer was about 1/4 the size compared to the control group with the combination. And the mechanism is increasing interleukin 2, among other things like inducing cell death. So that's something. There is a lab called RGCC in Greece that will isolate cancer cells from the blood, and if they find the melanoma cells in the blood, they can test many of these compounds to see if if these compounds can activate immune cells against cancer. So they'll mix the cancer with peripheral blood monocytes and see if they activate them and lead to cell death. So they're measuring cell death in these cancer cells after being exposed to an immune therapy. So it's another great way of helping to pick the best immune therapy, because I just mentioned a few things for IL-12. There's many things that affect IL-2. Astragalus is one of them, but there's another one called Borhavia diffusa, is another herb, and it is something found in India or in the southern U.S., and even eat the leaves of this plant as a vegetable in India. And they've gave this to animals with melanoma, and they found that the production of IL-2 was enhanced over 5-fold. So it really increases the IL-2. And what's nice is it decreases the levels of some compounds that will weaken the immune response against cancer, like one's called IL-6 and the other's called Gm-Csf. those compounds can be released by the cancer cells and cells that surround it and prevent the immune system from attacking. So that's another thing. That's not something they test at RGCC, but they do a test astragalus. Selenium is a mineral that will tell you that can help interleukin-2, and there's research on that as well, showing that the cancer doesn't spread that much in mice given selenium versus nothing, control group. All right, so that helps get the T helper 1 cells to activate the killer cells. But as I mentioned earlier, there are cells that can surround cancer cells, surround the melanoma and protect it. And one of them is called the myeloid-derived suppressor cell. And they find that these can be very abundant around melanoma. And they are cells that are produced by the bone marrow, but we should only have about 0.5% of them in our blood. And they find that patients with melanoma can have like 4 or 5% levels of these myeloid-derived suppressor cells in their blood, and even more around their cancer. And what these myeloid-derived suppressor cells do is they release compounds that basically inhibit the immune system from attacking. They release something called IL-10. They produce something called arginase, which basically paralyzes the immune system. And they found that patients on ipilimumab, if they happen to be forming a lot of these myeloid-derived suppressor cells, the ipilimumab will not work. They found that patients that had levels 4% in the blood did not respond to ipilimumab, but those that had less than 1%, which is more the normal level of myeloid-derived suppressor cells, responded. So it's something that can be measured. You can also measure things that induce the production of myeloid-derived suppressor cells to make sure they're not elevated at all. And one of them is something called Gm-Csf. Gm-Csf is a compound that can be released by cancer cells that will basically stimulate the bone marrow to release these immature myeloid-derived suppressor cells, they're called. And then those start to end up in the blood and end up in the cancer. And I just mentioned earlier that Borrelia diffusa, that Indian plant, not only increases IL-2 production, but decreases levels of Gm-Csf. That is something that can be measured. That lab, Pharmacin Labs, also checks Gm-Csf production. And you can also measure in the serum, but it's not present in that high of a level. So it's just interleukin-2 is a better thing to measure because you can measure that easier. But that's one inducer. And then another thing is something called IL-10. IL-10 is something that can be released by cancer cells that can cause these suppressor cells to accumulate. There's this mushroom called cordyceps that's very good for lowering IL-10. And there's a study done in the Clinical and Experimental Pharmacology and Physiology Journal, 2004, gave mice melanoma, and then they gave them this cordyceps mushroom, and then there was a significant reduction in the cancer, and the mechanism was lowers interleukin-10. It also affects another inducer of the myeloid-derived suppressor cells, which is called VEGF. So these are some simple things that can be measured. If you see IL-10 elevated in the blood or this thing called VEGF, it can mean that the cancer is trying to release these myeloid-derived suppressor cells from the bone marrow, causing them to accumulate around the cancer. So you don't want these things to be elevated in the blood. And so that's why I measure these things to make sure that I'm on the right track. Cancer does change. You might be responding to ipilimumab for a while, but as these cells start to accumulate, it will cancel out these immune therapies. And you can measure these things that induce the production. You can measure the myeloid-derived suppressor cells and do things naturally to help keep them from accumulating. Green tea is also something that contains a compound called EGCG that might also reduce myeloid-derived suppressor cells. Eating lots of cruciferous vegetables and flax seeds might also help because they also affect things that induce the production of myeloid-derived suppressor cells. And there's a study done, for example, in animals given pretty high doses of flax seeds, like 4 or more tablespoons. The higher they gave them, the better it worked. But they gave a large amount of ground flax seeds to these animals, and there was a great reduction in the number of lung tumors in these animals. And the mechanism is it can reduce these myeloid-derived suppressor cells. There's something in clove oil, that can also affect something that induces that. So there's all kinds of stuff that can be used. Now, once the myeloid-derived suppressor cells are out of there and these suppressor cells are there, now the killer cells can arrive on the site. So there's no roadblocks, should we say. Killer cells start to show up, and they should attack. There's a test that can be done where you take the killer cells out of the blood, natural killer cells, and you mix them with cancer cells. They use leukemia cells in the lab, but the research says if you're not killing leukemia cells well in the lab, then your killer cells aren't going to kill the melanoma cells very well. And so that's a lab test that can be done at pharmaceutical labs, and you can see. And then if that comes back low, there's a whole host of natural things that can make killer cells function better. One of them is another Indian herb called Macuti, or Biophytum sensitivum, where they gave animals melanoma, and it significantly reduces the spread to the lungs and the lung tumor formations from the melanoma. And how did it work? It enhances natural killer cells. It helps them destroy cancer better. So that's something that could be used if it tests low. I mentioned the AHCC, which is that compound from the cultured broth of shiitake. Can also increase natural killer cells. I use that very frequently. There's something also in shiitake, a different extract called the LEM extract of shiitake that has been shown to reduce melanoma growth by a third compared to a control, and it also increases the levels of killer cells and decreases TGF, that suppressive compound. Lastly, cancer cells can make something called fibrin, which protects them, and you can measure that in the blood, and if that is elevated, then reishi mushroom is another thing that can be useful, because melanoma can impair the killer cell's ability to attack. Well, I hope you got a good idea of how natural things play a role in melanoma. Next week, I'm going to talk about brain tumors, a particular one called the glioblastoma multiforme. Hope you enjoyed the show. This is Cancer Concepts and Compliments. I'm your host, Dr. James Belanger.
Thank you for joining us this week. Cancer Concepts and Compliments with Dr. James Belanger can be heard live every Tuesday morning at 6 a.m. Pacific Time, 9 a.m. Eastern Time on the Voice America Health and Wellness Channel. We hope to see you next week for another show.